Design tables provide a quick way to create multiple configurations of a part by adding dimension changes, feature suppressions, specifying a different material, among other parameters. In this lesson, I'll show you how to create a SOLIDWORKS design table and link it to an external Excel file. More specifically, we'll use the Excel file to control various dimensions of an assembly component. Whenever we're creating a design table, it's important to first consider what design parameters will be included. You can actually view a summary of design table parameters by going to the SOLIDWORKS Help and searching for Design Table Parameters. This is a summary of all the available design table parameters, along with the proper syntax and acceptable values. Now, as I just mentioned, I want to control a part's dimensions. However, notice that some parameters are specific to a SOLIDWORKS file. For example, part dimensions can only be added to a part's design table. So keep in mind that while an assembly's design table may control assembly feature dimensions, it cannot control dimensions of any of its part components. And I'll close the dialog box. And since I'm interested in controlling the dimensions of this component, I'll go ahead and open the part to switch to part level. Before I go ahead and insert the design table, I'll display the model's dimensions. To do this, I'll right-click on the Annotations folder and select Show Feature Dimensions. I also want to point out that some of the part's dimensions have been renamed, and this will make them easier to identify when inserted into the design table. Renaming a dimension is actually quite simple. I select the dimension and simply replace the text found under the primary value box. I'll rename this dimension Overall Length and click anywhere in the graphics area to accept the change. At this point, I'll insert the design table. The source box is where I'll tell SOLIDWORKS to use an Excel spreadsheet. I'll select From File and click Browse to reference the external Excel file. Before adding the Excel file as the design table, I'll right-click on it and select Open to quickly view its contents. Notice that the Excel file is empty. Now, this might not always be the case. In fact, you might already have an Excel file ready containing sets of different dimension values. However, at this point, we're only creating the design table. If working with an already populated Excel file, I recommend taking this approach first, and then copying the contents onto this new table. I'll close the Excel file and continue defining the design table. Notice this checkbox, Link to File. With this option checked, the model will be linked to the Excel table. With the design table linked, any changes made to the Excel file will be reflected in the model, and vice versa. Any changes in the model may be reflected in the Excel file. And let me show you what I mean. I'll leave this option checked and continue to the Edit Control box. The Edit Control box allows me to select between these two options. And like I just mentioned, I can either allow model edits to update the design table, where a change to a model dimension can override its design table value, or I can block model edits that would update the design table, where a model's dimension can only be adjusted through the design table. I'll go ahead and select this option, since I'm only interested in controlling the model through the Excel file. If you instead prefer to have a bidirectional editing capability, you might want to use the other option. I'll just click the green check to begin editing the design table. When creating a design table from scratch, it's important to know that the first cell, in this case A1, must be left blank and is considered as the design table's family cell. This cell marks the beginning of a design table's values, where part configurations are added to rows beneath it and SOLIDWORKS parameters are added to columns to the right. I'll specify the current configuration of default in cell A2 and continue to specify the table's parameters. I'll select cell B1 in the table and insert the overall length dimension as the first parameter. I'll do the same for length 1, length 2, and the height. Now keep in mind that you could also include other parameters such as feature dimensions, pattern instances, and suppression states. In our case, I'm done adding design table parameters, so I can click anywhere outside the table to finish editing it. If we turn to the Configuration Manager tab, notice the default configuration is now controlled by the design table. And if we look in the graphics area, we see that the design table dimensions are now displayed in a different color. If I try to change one of these dimensions, SOLIDWORKS doesn't let me, and instead tells me that this dimension is locked by the design table. If you recall, I chose not to let model changes update the design table. and since this is a design table value, I cannot change the dimension. The only way to change this value is by using the design table. Now I'll go ahead and save the part and exit all model windows. If I open the Excel file, you'll notice that the design table is updated. This external file will actually allow us to define and make any changes to the part outside of SOLIDWORKS. For example, I can change the part's default values, or I can create separate configurations and fill in the corresponding cells. Note that if a dimension value is left blank, the part's default value will be used. With my changes made, I'll save the Excel file and then close it. Now when I open the part back up in SOLIDWORKS, SOLIDWORKS prompts me if I want to update the model. Keep in mind that a part must be reopened in SOLIDWORKS for any external design table changes to take effect. I'll click OK, and notice all the changes are applied.